That's this on this grid, the remaining, okay? This shape. Okay, that's the first thing, a visual. The next thing is let's complete this table. So the side of the so the side of the larger square versus the area of the remaining shape. So they have some examples here. So the side of the larger square, if you look, I think they've done this one in the table for us. So that's the one we look at. There's a block of 4 here, and then there's this, 2 here. So that's, this is the one, the blue here has been shaded. So that's the shape that they put into the table for us to look at. The side of the larger square here this is side 3, I think. And then the area of the remaining shape is 1, 2, 3, 4, 5 blocks. That's what that's the pattern that we're looking at. So the rest of the table then, the side of 2 has an area of 3 remaining. So that's the first thing you should see here. And then we see 5, 7, 9, 11. You could use the diagram to work that out. For instance, we have this one here. This is 5 plus 4 gave the 9. And the side is 5. So this should be our table. Just 3 marks for that correct table. If there's just one blunder, I think you give them 2. If they get 1 right, I think you give them 1. Next one then, find an expression in terms of n for the remaining shape when the larger square has side n. So a relationship between these two numbers, I think it's a pretty simple arithmetic sequence. You can look at here, you're adding 2 each time for each one. And if you go back 1, maybe that will help. Perhaps. Some formula with, if you're adding 2 all the time, you know the formula nth term is going to have 2n in it. And then you need to figure out, is it going to be adding or subtracting a number? I think a little test here. 2 times 5 is 10, and I want 9. So I think I subtract 1. And 2n minus 1 is the formula that should be for 2 marks in part C.
If there's a no working out, it's still 2 marks, yeah.
For part C? Yeah, it just says find an expression. It doesn't say show how you figured it out. I think you can figure it out from the table pretty quickly. Sometimes you can, sometimes you can't. In the next question, then you have to find the area. They give you a situation to test your formula. The area of the remaining shape is 381. Work out the length of the side. So now we have the area of the remaining shape. We know the answer is 381. We've got to work back to find what was the length of the side here. This is just algebraic solving. I think 382 is 2n. And then if you divide 382 by 2, you get what n is. So it's 191, yeah. Okay, so that's another 2 marks. So you should be collecting. Don't think anything is too taxing so far. Yeah? Be skeptical a little bit with some people if they don't show working out. You could give them the right marks now, but if you just took the answer from the mark scheme just to do the homework, I don't know. Give them the marks, give them the benefit of the doubt. It's possible to do without any working out, so give them the benefit of the doubt. Okay. There should be some working out because it did say working out. All right, the next one then, something changes. Very standard for paper 6. They start off with an easy pattern and then they change that pattern somehow and you have to deal with those changes and maybe create a new formula. So let's look at this new formula. We got 3, 4. Okay, so we have a 4x4 grid here and these have been shaded out. Okay. So this square of side 2 has been so this is my square of side 2 in here, and it's removed from a square of side 4. So automatically I'm starting to think n squared and d squared for squares of side, or 2 different letters squared. The area of the remaining shape is 12. So I'm not even I'm just going to look at this pattern for a second. I'm going to just think about the formula could be. For squares, if I just call that letter, I think later on they want to use the letter n, so I will use the letter n. It's n squared take away another area squared, isn't it? Something like that. If this length is d. Presuming there's no relationship between n and d, I use two different letters, and that gives 12. But I think there is a relationship between the letters. The side difference is always 2. But we'll come back to that in a second. So you're always thinking, right, 3 squared take away 1 squared, or in this case, 4 squared take away 2 squared, and 5 squared take away 3 squared is given my answers here. This is the one with 4 squared take away 2 squared. So there's actually a relationship between these numbers. So don't write in 2 variables, only write in 1 variable, n. How can I replace d with n? What's the relationship between d and n? If this is n, what's d? It's 2 less than n, isn't it? So I could rewrite that a little bit better. N squared minus n minus 2 squared. 2 less than, because d is just, this one is 2 less, always. All right, you didn't need to do that. I was just showing you what my initial thoughts, what I've written here on the page were before I looked at the rest of it. Okay, I think you get, to complete this table, 8, 12, that's 16, and that's 20. So you could have done that with a visual. You could have drawn that in the sketch below. And then for part B, so that would be for 3 marks. You may use the grid. You don't have to use that grid. And 4n, I think minus 4 was the answer for part B here. Okay, but then you have to think about it a little bit more. The side difference, area of any remaining shape. Okay. So that was this is using what was found in the previous table back here. Like when the side is larger by 4, the area of the remaining shape is 12 and so on. How do I get that? Oh. Well, you could simplify this because we can do some algebra on it. We get n squared minus, by fact, multiply this out, n squared minus 4n plus 4, I think. So that's n squared minus n squared plus 4n minus 4. Is it something like that? So the n squares cancel. I'm going to have a 4n minus 4. Whether that's helpful or not, I think it is. So what? I did it really confusing. Maybe because this is just the way I did it, and I think differently than you guys. You probably thought maybe the most obvious logical answer, and I went stupid. So that was when the side difference was 2. And when the side difference is 3, I just did this again. N squared minus n minus 3 squared. And I worked this out. Now maybe you can, and I get 6n minus 9 for this. And I did n squared minus n minus 4 for side difference 4. You probably did this a way better way. 8n minus 16 I got for that, using the same process. So I'm filling in this table. And the first one then was n squared minus n minus 1 squared. And if we work that out, I'll do that one again just to make sure we're on the same page. That's n squared minus 2n plus 1. And then if I subtract that, that cancels, and on 2n minus 1 is the first thing in the table. So these are all my answers from the table. Changing the length of side of square, I subtract each time. You could have got that by drawing maybe, or just noticing the pattern after the first couple. It really was, yeah, but maybe... yeah. All right. My mind is mentally blocked to this is the way to do it. Anyone come up with a better way to do it, a quicker way? Yeah, I know, it's a long time ago, 6 weeks ago. Yeah, okay, 2, 4, 6, 8, and 1, 4, 9, 16. Yeah, you're looking at that pattern. Yeah. So you could have drawn it, yeah, you could have drawn it and just gone, oh, I'm counting up here, and it's... It's a simple pattern, yeah. So if you started to notice 2n minus 1 was the first one, 4n minus 4, well then you go in 6n minus the square, and was it 8n minus the next square. So you're just taking away square numbers because they're the squares. Okay, I made it a little bit difficult, but anyway. Okay. So most of you guys probably just noticed this pattern. Are we back? And most of you guys noticed this pattern, that's fine. I'll stick with this one if you prefer. So noticing in that pattern, how do I create this general formula in the next thing? Find an expression for n and d, which is the next question. So find an expression for n and d for the area of the remaining shape. Right. So I have to basically find the formula for this, yeah. What's the formula then? Yes, Alex. D. Okay. That's one way of... Alex came up with one way. Anybody else see anything written in front of them? Or... Olivia, you got something? Nope. Do you have something? The one we're on currently? Which one's that? Yes. 2nd, okay, 2, that's the same, minus d squared. Okay, so maybe you notice that just from these numbers that the second thing is the something squared, and it's the difference between the two, because the difference was 1, then the difference was 2, then the difference was 3 and 4. So maybe if you rewrote this pattern slightly different, 2n minus 1 squared, and then 4n minus 2 squared, and this then would be 2 times 1, 2 times 2. Then you notice that this could be the letter D if you want. The way I had it up on the board earlier on, you also could do, you just go n squared minus n minus the difference squared, which was the formula I was using earlier, which you don't like. Which gives n squared minus 2 nd here, or dn, minus plus d squared. And then the n's cancel, minus minus 2dn minus d squared. Anyway, anything that has that in it, or this in it, or this in it is okay. Anyone want to check their formula is correct? No? Okay. Next one. Find the, okay, so this is use your formula, and I think working backwards, let it equal 343. You get answer 28. 28, use the formula to get to, so 343 is equal to, whichever formula you use, let's use this one because it's the one Alex created. 7 times 2n minus 7, solve that. Divide by 7 first here, you get 49. 2n minus 7, subtract 7, or add 7 over, you get 56. And then n is 28. Okay. Next one introduces a triangle all of a sudden. Yeah. 2 times. Sorry. Don't want to consume your time. All right. Okay, you got some triangle. A, B, C. So A, B, C, A, C, B. Okay, so the sides opposite are the small letters of the angles or the corners here. Show that the area of this triangle, and they give you a formula. Nice. So area is a half AB sine C, which we should be vaguely familiar with from trigonometry. Show that the area of the triangle, of an equilateral triangle, with side length some n is that. So an equilateral triangle, what I do know about an equilateral triangle is that all these angles are 60 degrees. And if all the sides are length n, we just could call it n. Is that okay? No? Okay, now I'm just going to use the area formula. And wherever I use the area formula here, I'm going to get the exact same thing. Because if I use these two sides and this angle, or these two sides, this angle, or I'm going to get the same. So this means half AB sine C. So let's look at this one. Half this side, sine this angle. That's what it's saying. So a half this side, NN times sine 60. Now the problem here is you need to know what sine 60 is. And sine 60 is root 3 over 2. So that's a half n squared times root 3 over 2. N times n is n squared. And I just put it over 1 because I'm going to multiply everything together. And that gives, what way do they want it written? That, like that, in this order. N squared root 3 all over 2 times 1 times 2, which is 4. Okay? Yeah. Yes. Yeah. Paper 2, no calculator. Okay. Next one, an equilateral triangle is removed from a larger equilateral triangle. Okay. So one is removed from the other. One is 4, the other is 3. So if you have this, if you use this same diagram, 60, 60, 60, this one is 4, 4, 4. This one is now 3. This is the second part, 3, 3. And if I want to find the area of what is remaining, I would get the area of this, and I would subtract the area of that. We just know that the area of this is going to be n squared, which is now, this one is 4 squared, root 3 over 4, minus, this is going to be 3 squared, root 3 over 4. Yes. So what's 4 squared? Combine those two together. What's 4 squared take away 3 squared? That's 16 take away 9. 7 root 3 over 4. I know, yeah. It's always more easy than you think.
No, but it's always overcomplicated when it's not even that complicated.
Okay. Find the area in general, I think. Oh, 5 and 1. Okay, so this is just the side difference of 1. It's just 5 squared take away 4 squared, isn't it? This is 5 squared root 3 over 4 minus 4 squared root 3 over 4, because it says difference with length 5 and side difference 1. And that gives 25 take away 16, which is 9 root 3 over 4. So K is 9 for 2 marks. This is really not that tricky so far. Yes. What? There's nothing? Whose is it? Oh, so she gets what she gets. She's worked really hard on it. Maybe you could fill in a few answers for her. It might be nice. Yes. Yeah. Okay. Next one. We continue on. We're looking to fill in this table then. I think we have the hang of it now. Let's fill in the table. So side of larger triangle, area remaining. They give us one. This one we created, I think. So that's 7 root 3 over 4 given. We've already worked out 9 root 3 over 4. This one's going to be 5 root 3 over 4, I think. And the first one, yeah, 3 root 3 over. Okay, that's what we're looking for in the table. Okay. Okay. Right, and this is maybe the most difficult part, I think. Find the expression of n and d for the area of the remaining shape of the larger. So just find the formula for this, basically. I think the formula I would start off with, if this is n squared root 3 over 4, what's the other one? Charlie, you good? I did the same thing I did before. I just said, oh, it's n minus whatever d is squared root 3 over 4. No one did that.
Yeah, that next question.
All right, where did I come up with that from? If we go back to this diagram, that one down there,
Just put d equals to 1, then you do d equals to 2, d equals to 3, and then you just
what? Yeah, you could do it a different way. Yeah, I think the fact that these two this is the same thing I had earlier on. These questions are linked. So how are they linked? Maybe you didn't do it this way. Maybe you just saw that the numbers here, 3, 5, 7, 9, came up before. How do we get 3, 5, 7, 9 from 5, 4, 3, 2?
You just use square and then you minus the difference.
Yeah.
So 4, so 2 squared minus 1 squared is. And then you just do the same thing. Then you use that area thing, the area thing is its half, because you're going to get the same thing.
How did I do this? How did you do that? Oh yeah, there's a different way, no? It's linked to the previous question, I think. Isn't it the same formula? Yeah. Okay, I'll do this. This is what the question tells us. The difference in the side. One is some length different than the other. I'm going to just work out this. So this is n squared root 3 over 4 minus n squared minus 2nd plus d squared root 3 over 4. Now they both are over 4, so they can be combined, and they both have root 3, so they can factor out the root 3 in front. So they're all over 4. I have n squared minus 2, so that's plus 2nd, minus this, all with a root 3. They're all factored by root 3. This cancels. And I have a 2nd minus d squared times root 3 over 4. Now that's it.
I know this, but you put it into like a
That's or a version of that. You can factor out the d out of this as well. So
You wrote root 3 over 4. D bracket 2n minus. Is that still right?
oh, what'd you write?
Is this for E?
What'd you write?
3
Yeah.
over 4. And then D bracket over bracket 2n minus D.
Yeah, that's the same. Yeah. Okay. There's probably some attempt marks there. I'd say if you got root 3 over 4 multiplied by some combination of n and d, you probably could give a temp mark. I don't have the mark scheme with me. Yeah.
It should be in the simplest form, right? And isn't that one not the simplest form?
This one's not.
Yeah. That one is.
This one is.
Yeah.
What's the difference?
Can be simplified more.
That's the exact same. It's saying the exact same things. Nothing is simple. There's no. Nothing's been factorized. Everything's the exact same.
Isn't that thing more simple?
This is more simple than this? No. It's exactly the same amount of simplification. Yeah. You've literally written the exact same amount of things, for example. All right. Let's move on to the modeling question now. So this is the escalator one. Oh, we did that. Am I going backwards? No. Okay. Lucas, be quiet. Every step of an escalator travels at a speed of 1.8. Show that the distance step moves in 1 second is 0.5. Okay, so big change of pace here from geometry kind of looking thing, trigonometry to speed, distance, time. So, show the distance step moves in You have to show that. Okay, you got to get its speed for every second, or the distance traveled in every second. So at the moment, it travels 1.8 kilometers per hour. That's, if I want then to look in meters and seconds, convert these both to meters and seconds would be something I do. So that's 1,800 meters by multiplying by 1,000 in an hour. How many, well, that's how many seconds in an hour? Seconds in an hour. 60 times 60. If you want to do that, turn it into seconds. 60 times, so it's meters in 3,600 seconds. That's the speed it currently goes at. Now, if I want to get, what do I want? I want to get the seconds down to 1 second. So you have a calculator here. If I want to get this down to 1 second, I just divide this side by 3,600 as well, and I get 0.5. Something like that, some sort of showing that you've multiplied by 1,000, divided by 60, 60. There's probably maybe an easier way to show it. I seem to overcomplicate things. All right. Next one. The length of the escalator is 40 meters. Find the time in seconds. So that's 80 seconds. So if it goes a half a meter in 1 second, if the length of the escalator is 40, if this is 40 meters, how many seconds? So that's 80 times more. So you could divide 40 by 0.5 to figure out, but it's 80. Okay. Next one. 80, yeah. Matt travels up a different escalator. The length of the escalator is 24 meters. The escalator is not. All right, starts. The escalator is not moving. It takes Matt 50 seconds. Find his speed. So 24 meters, 50 seconds. Speed is distance over time. When I divide this, I get 0.48. What's the unit meters per second? Meters and seconds.
If they did put meters per second, is that?
Give it to them correct. I don't have the mark scheme with me, but I think it's okay. The escalator is moving now. Show his speed walking up the escalator is 1.28. So the speed of the escalator is... So this is his speed. His speed is now going to be added to the escalator speed, whatever the escalator speed is. So the escalator speed is the 24 meters it covers in, it's faster. What was it, 30? 0.8. So that's the plus these two together, and you get 1.28. The two speeds, because they're going in the same direction, added together would just be 1.28. Find how long it would take him to walk up the length of a moving escalator then. So you have 24 meters, and you know his speed is this. So time is distance over speed, so that's the distance is 24 meters. The speed he now works at is these two speeds added together, his walking and his... You all right? Is 18.75 when we calculate. Next one. Where are we at? Yes. Yeah, sure. All right, so we're moving along. Matt walks down the escalators. When it's not moving, it takes 24 seconds to walk down the escalator, which is a 24-meter escalator, so that's 1 meter per second. Show the speed walking down. So the 24 meters in 24 seconds is 1 meter per second. I think that's pretty straightforward. That's not the answer. Show a speed walking down the escalator 0.2. So the escalator is going up at 0.8 meters per second, going down at 0.8 meters per second. So if I take away that 0.8 meters per second, we figure out what speed he was going. So that's the 0.2 meters per second. Next one, for how long will it take Matt to walk down the length escalator when it's moving up, or is it the same speed? Oh man. So the time will be the distance, which is 24, divided by that speed of 0.2 you've just created, which I think gives 120 seconds, which is, or 2 minutes you could write. Mm-hmm.
What's question for A3? Within 19 seconds for A3. So 6A3.
6A3 was, it doesn't sound right, 19 seconds. 18.75.
If they round it up, we don't give the...
Oh, this, take it 1 mark off them because that's too much rounding. It should be, if they did 3 civic figures, 18.8. Okay. Next one, you have to say, give reasons why this is a good model. You'll have to do some sort of okay. So we got this new thing, an escalator of length 6.2. Giselle, let's go. Thank you, Lizzie. 6.2 is the new length, so that's the new distance. That's why the top of this is 6.2 of each case. And one is, this is about a guy who goes up and down. So this is some sort of explanation to say that this is the distance over the speed up plus distance over speed down. Or something to say you're adding his time going up or time going down. You're adding those together and that will this is for time. The one on the left here is for time up, and the one on the right is for time down. So if you said the one on the left, that 62 divided by 0.8 plus v that's for time up, minus or plus time down. The other one is time down. Something like that is what we're looking for. Yeah.
What would be like 1 mark and 2 marks? Is it 1 mark for like, say, up, 1 mark for distance?
What'd they say?
Well, is it per reason? Because it says reasons why, so 3 reasons. He wrote like to find significant distance over time.
Yeah.
And then he said we can do distance divided by speed, and then he wrote the speed. So he didn't say it was up and down.
I think 1 mark. If you say time is distance over speed, that's 1 mark, and then you have to split it up into why this is a good model is that each of these, one is up and the other is down. Yeah. I think that's 1 as well. They have to say that it's there's something going up and something going down added together to get everything. Okay, show that this then can be simplified into a different form. So this is one that even if you didn't understand where this came from, you should be able to do the next part of the question because it's just algebra, just showing your algebra skills of adding 2 fractions together. It's not the easiest thing in the world to add together, but we'll try it. So we have t is equal to 6.2 over 0.8 plus v plus 6.2 over 0.8 minus v. So we're looking for a common denominator and add the 2 together. The common denominator is going to be this times this. So I'll write that down, 0.8 plus v times 0.8 minus v. That means that one will have to multiply here, 6.2, for it to be over this denominator, and the same on the other side. So you can think of it as a cross multiply, even though that doesn't really make sense, but if you want. All right, so when I multiply this out, you've helped with a calculator, but 0.8 times 0.8 is 0.64 in the denominator here. The middle 2 terms are going to cancel because one's plus, one's minus, and we get minus v squared. Is that what we wanted in our answer? Yes. On the numerator, we have to work this out. Oh, I think if you do work it out, you get 9.92. I haven't done it out bit by bit. And the v's will cancel because it'll be minus 6.2v plus 6.2v, and then add together these two numbers. When multiplied together, you get 9.92. Okay. Next one, when the speed of the escalator is 0.4, find how long it takes Matt to walk up it. That's putting in 0.4 in here, which you could do once again without doing any of the other previous parts, and you get 20.67 or 20.7 if you did to 3 significant figures.
So 20.6.
I'll give it to you. Fine. Next one is he waits for 10 seconds before he goes up. So what's your model? It's this plus 10, yeah. That's it. It's just this plus 10. As simple as that. Sketch the graph. This is where you pull out your calculator and you sketch the graph on the calculator. You don't try and do it without a calculator. Well, you can, but it'll take a long time. So you try and put this into the calculator. You should end up with something like this. They shouldn't cross over here. You're looking for something like that.
Is that only 4 marks for just drawing the graph?
Yeah.
So you have to like write where it's intersect, right?
Probably, yeah. I don't have that.
But the intersect is later on.
I think you have to use it in a... I'll check the mark scheme. Yeah, you got to label it at 1.28 and 25.5. So I think this has to be labeled 1.28 and this is 25.5. The mark scheme then it says it's 2 for the shape and then 1 for each of these. Okay, so if you look at the breakdown, the 4. You can see then the total time for Matt to walk up, wait, and walk down is 138 seconds. Find the speed of the escalator. So this is where you go on your calculator, say y is 138, because y is the time here. Y is 138, so you find the speed. I think it intersects here. If this is y is equal to 138, you find that this x is 0.75. So the next answer to part 3 is 0.75 using this. Use your... No, just 0.75. You could do it on the calculator. Part 4, give a reason why the model is not valid when velocity equals 5. Any reason why it wouldn't work when velocity equals 5? You can say that. The time is less than 10 seconds. Or you can say the speed of the escalator is faster than maths, so that's not possible. And the last one, what range of value for V is the model valid? The model would only be valid if V is less than 0.8 from this. If V is less than 0.8, because 0.8 squared makes 0.64. So we're looking for a V less than 0.8. Because the only thing that makes this not negative here. Yeah. Up to 0. That's fine. Equal to, equal to, it shouldn't be equal to 0.8 because that will be divided by 0 here and that will be a mess. I'll give him a mark. We're generous today. Yes?
Are you allowed to type in your calculator to find out y value?
Yeah.